Welcome back to the terminal. Let's pick up where part 1 left off with 8 more failures that quietly bite real systems. We're tackling cron jobs that silently skip, SSH refusing connections, path issues that hide your commands, and the classic disk full message when there's still space left. Same discipline as before: observe, isolate, diagnose, fix, one change at a time. Before we dive in, a quick refresher on the loop will run for every scenario. Observe the exact symptom. Read the actual error, not what you assume it says. Isolate which layer is failing: kernel, service, network, or config. Diagnose with real commands and read the output carefully. Then fix and verify the fix actually held. And the golden rules still apply. One change at a time and back up any file before you touch it. First scenario: a cron job that just never fires. There's no error in your inbox, no output anywhere. It's like the task simply doesn't exist. Start by observing what's actually scheduled with Cronable. Confirm the cron service is running via SYMPTOM DIAGNOSE, then grep size log for cron entries to see if it even tried. The fix is almost always the same gotcha. Cron runs with a stripped down path, so use full paths like alb usr bin Python 3 and redirect output to a log file so next time you'll actually see what happened. Next up, the whole box feels stuck. Load average climbing, yet top shows the CPU mostly twiddling its thumbs. That's the classic signature of disk I/O wait. Confirm it by watching the %BUA column in top, then drill down with IOStat, X1 to see per device pressure, and IOTop to pin the noisy process. Once you've got the PID, you can deprioritize it with Ionis, stop the offending service outright, or run smart CTL to make sure the drive itself isn't dying on you. Shifting from a sluggish disk to a host that won't even let you in, SSH says connection refused, or it just hangs. That wording matters. Refused means nothing's listening on port 22, while a timeout points at a firewall or network problem. So verbose SSH into it, check SSHD's status, and run sstrlnp pipe to grep 22 to see if the daemon is actually bound. If it's not, start it with systemctl, allow 22 cp through UFW, and enable it so it survives the next reboot. Once you're back on the box, here's a classic head scratcher. You installed a tool, but the shell swears it doesn't exist. Start by asking which my tool. If that comes up empty, echo your path and peek inside the usual bin directories to confirm whether the binary's missing or just hiding. If it's there, call it by its full path once to prove it works, then append its folder to path and drop that export line into your bash ORC so it sticks across sessions. Package managers are the next usual suspect. When apt or DNF throws broken dependencies or refuses to run because something's locked, resist the urge to start uninstalling things. Read the exact error first, then run apt update and apt install to see what it thinks is wrong, and check for lingering lock files under varlib.dpkg. The fix usually falls into 2 buckets. Let apt repair itself with fix broken install and dpkg, configure AA, or if a previous update was killed mid-run, remove the stale lock by hand so the next command can actually proceed. Now, a sneaky one, a drifting clock, when timestamps in your logs look off, or TLS handshakes and Kerberos tickets suddenly start failing for no obvious reason, suspect the system time before anything else. Run timedetectl to see the current state, date to confirm, and check system time sync to see if sync is even running. The fix is usually a one-liner. Set NTBIA true to let the daemon take over, and while you're there, pin the right time zone so logs read correctly. Next up, zombies. When P shows a pile of defunct entries, that's dead children whose parent never called wait to reap them. And if they accumulate, you'll exhaust the PID table. Don't bother trying to kill the zombie itself. It's already dead. Instead, find the parent with PS. PIDIP on the zombie's PID, then send that parent a SYGLD, restart its service. Or, if it's misbehaving, kill the parent outright so init can clean up. Here's a classic head scratcher. Writes fail with no space left, but df ACOH says you've got gigabytes free. The trick is DFI, you're out of inodes, not bytes. Some directory has spawned millions of tiny files, probably a runaway cache or session folder. Find the culprit by grouping paths with find, cut, and unique C, then clear out the offending directory. Same lesson as always. Read the actual error, don't assume. That inode trap is a perfect lead-in because the same listens keep showing up across all 8 scenarios. The error message rarely tells you the full story. Disk full might mean inodes. Refused means nothing's even listening on that port. Always check whether the service is actually running before blaming config. Remember that cron and shell scripts run with a minimal path, so spell out full paths. And read the exact words of the error. Refused versus timeout. No space versus inodes. Those words are your fastest clues. And those clues live in the logs. So let's map out where to actually look. For service level issues, cron jobs, SST, timesync, reach for journalctl-u and the service name. SSH login attempts land in auth.log, package install history in var log apt. And on Debian, you'll often see cron output in syslog2. For hardware and disk I/O complaints, dmesg-t gives you readable timestamps. And the real trick, scope everything with journalctl, since 1 hour ago to zoom in on the moment things broke. Now, before you dive into any one scenario, run this 5-question checklist in order. It'll point you at the right problem fast. First, is the daemon even running? System status. Second, what does the log actually say? Journalctl-u. Third, if it smells like disk, check both bytes and inodes, df-h and df-i, because a full inode table looks empty on a normal df. Fourth, command not found, which and echo path. And fifth, if anything involves certificates, cron, or auth, check the clock with time-detectl. 90% of the time, one of these 5 lands the hit. Before we hit the scenarios, a quick detour through the anti-patterns that waste the most hours. Trusting df-h alone, don't. Inodes fail silently, while bytes look fine. Assuming cron inherits your path, it doesn't. Cron runs with a bare environment, so use full paths in your scripts. Trying to kill a zombie directly, pointless. It's already dead. You signal or restart the parent. And confusing refused with timeout. Refused means the service is down. Timeout means a firewall's eating your packets. Totally different fixes. Now, how do we stop these problems from coming back? 4 habits pay for themselves fast. Monitor inodes and IO weight, not just disk percent. That's how silent failures get caught early. Always redirect cron output with append, and 2 greater than in 1. So when a job dies at 3 a.m., you have a trail. Run NTP everywhere because clock drift quietly breaks TLS auth and your logs. And harden SSH from day 1. Key auth. Tight firewall rules. SSHD enabled on boot. Keep this cheat sheet close. These 9 commands cover most of what we've worked through. crontab-l, ss-, tlnp, and time-detectl on the left for scheduling, ports, and clock state. Middle column is your IO and environment check, IOStat, echo path, and ps-grep-z for zombies. And on the right, IOTop, df-i, and apt fix broken when packages get tangled. Memorize 3 or 4, and you'll diagnose faster than you can open a browser. Now let's tie all 8 scenarios together in one view. Cron silently failing usually traces back to path, lists the jobs, and use full paths. SSH refused means check the daemon, then the port. Package errors, apt fix broken. Slow disk, narrow it down with IOStat, then IOTop. Command not found is almost always a path gap. Clock drift, re-enable NTP. Zombies, signal the parent. And inodes full, df-i, then sweep the tiny files. Same discipline every time. Observe, isolate, diagnose, fix. If you take away just 4 ideas from this session, make it these. First, the label can lie. A disk reported full might really be out of inodes, and a connection refused means nothing's even listening. Second, always check the daemon before chasing anything fancier. Third, mind the environment. Cron scripts run with a bare path, so spell out full paths. And fourth, prevent the repeat. Monitor inodes and I/O. Log your cron jobs, keep NTP on, and harden SSH. And before we wrap, here's a quick glossary you can pause on. An inode is the metadata record behind every file. Run out of those, and the disk looks full even when it isn't. IOIT is CPU time stuck waiting on disk, your early warning for storage trouble. A zombie is a finished process its parent never reaped. Path is where the shell hunts for commands, the reason cron jobs love to fail. NTP keeps the clock honest, and a daemon is just a background service like SSG or cron. So that's the through line. The error is a clue, and your job is to read it closely before touching anything. Cron, disks, SSH, path, packages, clocks. Zombies, inodes, 8 very different failures, all solved by the same calm method. Observe, isolate, diagnose, fix. If you missed part 1, head to dargslan.com for the first 8 scenarios. And if this helped, subscribe, like, and share. I'll see you at the next terminal.